Are you being bullied by math letters? A prime example is standard form written in this form, which leads to using the quadratic formula. Now that's being bullied by letters, but we're about to take that in a different direction today. Because what you're looking at right here is now a new way that we could write a quadratic equation, and now we have some new letters to bully you, the h and the k, which stand for the vertex h, k. Now at first you say, oh man, a new form, but I'm going to first prove to you that you are already familiar with this form. If you've been working with translations, and I know you have, then you've already been using this form. For example, you take the parent graph y equals x squared, and if you attach a minus 3, you translate it down 3 units. That minus 3 is similar to that k. Let's keep going though. If you take your parent graph and you attach this minus 2 to the x, you've now translated it 2 units to the right. That minus 2 is like the h. You could put them all together and you would get a translation 2 units to the right, 3 units down, and that is where your eyeballs start looking to think about the h and the k. So when you start seeing this form of the equation in place of that form, just realize that this is just being written in a style that helps you understand the translations better. So let's look at a few of these in action. You're going to be presented with a quadratic equation in this form instead of standard form, and you're going to find the value for h and k. So for example, if I looked at this, my brain says, hey, translation right 5 units, upward 3 units. But if I think about this form, and in fact I could write it right underneath there, I can now start to spot the values for h and k. Minus h, minus 5, that means h must be 5, plus 3 plus k, that means k must be 3. And yes, in that equation, my h is 5 and my k is 3. And in fact, once I know my h is 5 and my k is 3, that also corresponds with the coordinates of the vertex, because the vertex is coordinates h, k. That's what you see up there. That might be confusing to you, but it's not once you see it in action. For this equation, it's translated from the parent graph over to that location. In this next example, what is the value of h and what is the value of k? If you were given this equation, you would imagine this written right underneath it. So my h must be 5. And now be careful here. The k, it's supposed to be plus k, and that says minus 7. So you will have to do the little switcheroo. You would not say k is 7, you would say k is minus 7. And if I were to look at this as a translation, it would be right 5 down 7. Right 5 down 7. There's my vertex, and my vertex is h and k. H and k is the vertex that goes into there. In this final example over here, I take a look, I can tell myself, hey, I'm translating left 4 units, upward 8. If I had to think of my h and my k, left 4 units, upwards 8. So my h and my k in that situation is negative 4 and 8. So hopefully what you're getting at is this is just a different way to describe a quadratic equation, and math people always like to put in letters where you wish there were numbers. As long as you just say, hey, what would the translation be in that situation, you could probably easily figure out what your h and k are. So in keeping with that theme, if I gave you this equation, you could easily say those are the vertex, or that is the vertex, and that is your h, and that is your k. or the coordinates of the vertex after you translated the parent graph 5 units to the right, 3 units up. Same thing over here. This tells me translate left 4, up 8. So my parent graph vertex goes left 4, up 8. This is now my new coordinates of the vertex, and that is also my h and my k. So I know in this situation h is -4, k is 8. It's just assigning letters to this situation where you wish there were numbers. One final piece, and it's something you already know. I originally stated the equation like this, but you will often see it with an a written out in front. That a is no big deal. You already know what that does, and I'm going to show you as we look at an example. If that a is a negative, then you know that graph opens downward. For example, you know the parent graph y equals x squared looks like that. If you were given y equals -x squared, you would know that's just a reflection about the x-axis, and it opens downward. So when you see that a as a negative or -1, you know you're in that situation. If you see that a written out here as a fraction less than 1, then you know you're going to have a horizontal stretch or a wider parabola. So it would be more like this. And then finally, if you see that a being bigger than 1, then you know you have a vertical stretch, or it's a skinnier graph. In this case, it would be a negative, so opening downward, and skinny. So the vertical stretch would make that parabola very skinny. So the goal of this video was to remind you that math people like to bully you with letters, but you're already familiar with this form once you learn translations. We're now just formally giving an h and a k to the situation.